And thought I had my agenda in here. I know I did. Okay, just a second here.
A day off, huh?
Say what?
A day off then?
Wait, you mean a day off next Monday, or what? What do you mean a day off?
No, since you can't find your agenda.
Oh, right. Well, no, it doesn't work that way. Okay. I can find it. I know. You see, it's right here. I just didn't have it in Canvas. I thought I did have it in Canvas. Anyway, I'm going to stop sharing, and I'll just share the agenda without Canvas. So, okay, here's the agenda. So we're going to review the quiz. We'll review some homework. We'll look at 337 for sure, and anything else you want me to look at. Then we'll do the lecture on 5.1, and we'll talk about the homework. Then we'll have lab problem solving. In other words, we'll just do some of the questions out of the homework area. And just to remind you that next Tuesday is the second quiz, and it's on 4.5 and 5.1. Okay, just want you to remember that. So having said all that, let's let me go to Canvas and we'll share the I'll share the quiz with you right here. You guys did very well, by the way. All three of you did good, so I'm pleased. And the other, I have to apologize. The other thing, for the quiz that you did was a little different than the quiz for the other class. You actually did a little more than the other class, so you did extra. It wasn't supposed to work out that way, but it did. But in the future, it'll all be the same quiz. Anyway, let me download. Okay, and make it a little bigger. Okay. So number one was just translating an algebraic equation into a word. Okay, just a literal word description of it. And what I was looking for, and what I didn't get in most cases, but I took it anyway, but I was looking for the quotient. When we say x over y, that's really the quotient, but I allowed, if it was x divided by y, I said that was okay. And the other word, on 5x, I was looking for the product of 5 and x, but if you said 5 times x, I said it was okay. Everyone got PEMDAS, that was good. And these were all done very well. You just had to do your algebra. On this one, you had to remember, of course, that you get 2 plus 1 to 3, divide into 9, and do the order of operations. In other words, you follow PEMDAS to do it. You get 21. The second one, you get 58. Nothing hard about this. This one, 13. I think everyone got these right. And this one was 27. Simplify the following expression, combining the like terms. And I think you might have had a 5B on that one. I can't remember, but I had taken a couple of things out of the original quiz I had, but unfortunately, you guys got the original quiz. But you did fine, so that's the good news. I think you did 2 and 6, solve for the variable and show check your work. And I think if you did one of the two, I said it was great because that's what I had the other class do. Yeah, there was no issues on this. You just had to take this -1 and plug it back in and make sure the equation balanced at the end. And that was checking it. On these three, I was looking for whether it was conditional, identity, or contradiction in the number of solutions. And you all did that fine. The first one was n is equal to 7, and there's one solution, so it's conditional. The second one, 12 did not equal -33, so it's contradiction. There's no solutions. Nothing works. And the third one was the other one, the infinite solutions. It's an identity. You could put any value in X and this equation would still be balanced. Okay. And this one, I was just looking for what you did first, and that was distribution. So I'm not sure if some of you did the whole thing. I can't remember, but I know some in the other class did it. But you all did very well. Okay, so I'm pleased. The second quiz will be like this. It'll be a lot of graphing and providing graph paper for you. Again, you guys are just going to have to take copies of it and send it back to me. Okay, just like you did the first one. Okay, so I'm going to stop sharing that. And now let me go to the book, and let me go to the homework. I'm in the right section. Maybe I'm not. Let me get 4 point or 5.1. I mean, we need 5.1. Just a minute. Okay, we're in 5.1. And make sure I do this right. I'm trying to get to the homework. Just bear with me. Here we go. Okay. So Tessa's question is 337. I'm looking for 521. I know, right? Sorry, I'm at 5.1 and not 4.5. That's the problem. 520. I want 521. Just a minute. Good grief. I got to go to the top and do this again. I'm sorry. Just a minute. I lost it. Just a minute. Okay. Oh, I can't. Too many things open here, and they're. Oh, there we go. They're all piling up. Okay, I want 4.5. Sorry. Okay, now I'm 4.5. And I want 521. Almost there. Finally. And I need to make bigger. Okay. Get this thing out of here. Okay, so 337. It's a linear equation. And the problem is P is equal to 28 plus 2.54 W models the relationship between the amount that Randy's monthly water bill is in P dollars and the number of units W used. And so the first thing you had to do was find the payment when no water was being used. So that just ends up being the y-intercept or the constant or the $28. So when W is equal to 0, then P is equal to 28, right? So just think of it that way. So when you graph this on the y-axis, it's going to be P. On the x-axis, it's going to be W, okay? So it ends just like an XY equation where we're using the variables P and W. Okay, so that's the first part. Find the payment for a month when Randy uses 15 units. You plug 15 in here. You solve for it, right? And I don't remember what it is exactly, but 2.54 times 15 plus 28 is your answer.
Right, which is $66.10.
Okay, gotcha. Well, that's right. I do remember that number now. And then interpret the slope and intercepts of the equation and graph the equation. So like I said, the slope is going to be the 2.54. Okay, the
I have a
y-intercept.
question. Sorry, I didn't
Okay.
mean. When
Yep.
you're graphing like
Yes.
something like this, does the X and Y intercept, does the scaling have to be the same?
No, it doesn't. Good question.
You get what I'm saying? Because
Yep. No, it doesn't have to be the same at all.
sometimes the scaling is like totally different, and it's hard
Yep.
to like, you know what I mean?
Yeah, I know what you mean. You try to make it so that the graph looks reasonable and you can get everything on the graph. And sometimes you on the x-axis you may have to make it in tens. It may have, it may have to be a different scale than what the y is. It doesn't matter.
So does
Okay.
that mean like it's okay if like people's graphs are going to look different then?
And that's fine. Yep.
But
There's no problem
it's
with
still
that.
portraying the same information. Is that correct?
Yes. Yep. As
Okay.
long as you identify what your scale is, you make it obvious that one tick is equal to 1 or is equal to 10 or is equal to 2. I don't care. It doesn't matter. As long as you indicate what each axis is and what the scale is, that's fine. Yep. There's nothing wrong with that. Okay. That's a very good question. But let's go ahead and graph this one. So what it would be, and what I'm going to do, I'm going to go to Desmos to graph this thing. Let me see if I can get that up. Desmos is right here. Now let me stop sharing, and then let me share Desmos. Yeah, it's right here. Okay. Okay, so can you guys see a screen called Desmos? Oh, I've got my it's just all cluttered up with everything I've got here, which doesn't help at all. Just a minute. Lord, I can't. Just a minute. The bars. Okay, here we go. So if I put the equation in here, P is equal to 28 plus, I'm not sure if I have to put X and Y in here. I may have to change this, but just a minute. No, I can do this. Okay, so do you see, can you see this graph? I don't know, what can you see a graph? Everyone? You can, okay. Okay, the vertical axis is P. The horizontal axis down here is W. It intercepts at 28, that's what this shows right here, and it's got a slope of 2.54. So if you go over to 15 units, 15 units would be right here, and it would intercept at 60 plus, 66 right up here. That's what Y would be. So that's how you'd graph it. The key is to know what you want the vertical axis to be and what you want the horizontal. The vertical is always the dependent variable. It depends on what value you'd normally put in here. And so the independent variable is W. That's what you change W. Every time you change W, it gives you a new P, right? A new cost. So that's how you would graph it. Any questions on that?
Yeah, I guess I was like trying to turn the 2.54 into a fraction to make it easier to graph, and I guess I'm not understanding how you do that.
Well, that's a good question. The way you would do it on this, you would actually take this, you would plot a point. I would go over here to 15 units and plot a point here, and then go up to 66, plot a point there, and then draw a straight line. That's how I would graph it. Does that make sense? Just by using the equation, right? By adding 28 plus 2.54 times 15 gives you 66.1. So when W is equal to 15, P is equal to 66.1. Put that point on this graph, and then line it up between that point and the y-intercept, which is 28 and 0, or 0 and 28, and draw a straight line. That's the way I would do it. Does that make sense? Okay. Any other questions on the homework? It's a good question. No, there's nothing wrong with it. There's no silly questions. That's a good question. Okay, so if you're okay with that, I'm going to get out of Desmos and we will, yeah, we'll go back. Okay, so now I'm going to go into the lecture part right here. Okay. And I'm going to, these bars are driving me crazy. They're all over the map. Just a minute. I'm going to find 5.1. Ah, Lord, it's not. Okay. Find 5.1. Okay. So I found 5.1. Just a sec here. Too much. Okay, I'm gonna enlarge it. Can you all see my screen? If I get the clutter out of the way. Just a minute, I'm gonna make it bigger. Okay. Okay. Okay, solving systems equations by graphing. That's what this section is all about. Okay. We'll just start right down here. So what you want to, we're talking about systems of equations. So that means two lines, okay? More than one line, that's a system. And so and most of this chapter is on determining whether an ordered pair is a solution to the system of equations, okay? By that I mean, is this ordered pair, this x and y value that you compute, can you put that in both of these equations and does it work? Does it satisfy both equations? If it does, then it's a system of equations. Here's the first example. You've got 3x minus y is equal to 7 and x minus 2 is equal to 4. So the question is there a solution to this and what is the solution? When you write this in the books, it'll have a little bracket around both of these together. Well, I don't do that because I can't put that bracket in, but that means that's a system. I would just say that 3x minus y is equal to 7 and x minus 2y is equal to 4 is a system, and it just identifies it as a system, okay? So they're asking the question, is the ordered pair, which is when x is equal to 2, y is equal to minus 1, is that a solution? Well, how would you do that? Without graphing, you would take and put this point into both of these equations and see whether it works or not, whether it balances. Okay, so here you'd put the x is equal to 2 into the top equation, so you get 3x minus y. Y in this case is minus 1. So it becomes 3 times 2 is 6, minus a minus is a plus. So it becomes 6 plus 1 is 7. So 7 is equal to 7. So that top equation balances or is correct when x is equal to 2 and y is equal to minus 1. Okay, it's a solution. Okay, now you see whether that solution can plug into the other equation. You do the same thing. For x, you put 2, and for y, you put minus 1. So it becomes 2 times minus 1, which is 2. With 2 plus 2 is 4. 4 is equal to 4, so it's true. So therefore, this ordered pair is the unique solution for these two lines. Okay, it's where these two lines cross. It's really, I say that too much, but it's really that easy, that simple. Okay, that's what that means. So try another one. Let's try another ordered pair. Is this ordered pair? Does this work? A 3 and a 2. Well, you can put it into the top equation, and sure enough, it is true. So 3 and 2 is on this line, on that top line. But when you put it into the bottom equation, x minus 2y, it doesn't work. So it's not on that equation. It's not on that line. Okay, it's only on one line, not two of them. Does that make sense? You know what I mean is when I say that. I'm gonna share 3x minus y is equal to 7x minus 2y is equal to 4. I'm going to stop sharing, and I'm going to share. Okay, I'm going to share my, I lost my whiteboard too. Just a minute. Just a minute, I've got to get my whiteboard up here. Okay, just a minute. Okay, so I got it. So it's okay, so now okay. Now I'm going to share my whiteboard. It's right here. Okay, so can you all see my whiteboard now? Can you see a board?
Yes.
Good. So looks like that. The first equation was 3x minus y is equal to 7, right? Convert this into a y-intercept equations. It's going to be y is equal to 3x minus 7. I'll make sure this is right. Minus plus. I think that's right. So this one here, to graph this one, you just go to minus 7, right? I wish I had an easier way of doing this. Okay. So that first one is down here somewhere. That's where it crosses that's the y-intercept, or that's the b value. I want so here. And that second, and then it's up 3 and over 1. So the graph goes like this. So I don't know if I can do this. It looks like that. Okay, that's the first equation. The second equation is x minus 2y is equal to 4. So it looks like that. So I'm just doing this quickly. So y is equal to 1/2 x minus 4. Okay, so that's what that second equation looks like. If I did it right, so I just move that over that side, and then divide by 2. Oh, this should be 2, not 4. Okay, so it would look like that. So when you graph that, go up here and change my. So when I graph that one, make it a different color. The y-intercept is minus 2, so it's up here, and the slope is 1/2, so it's up 1 and over 2. So let's see if I can do this. So it's like that, right? That's the second one. And it said on, and what we did is we figured out what this point was, right? This is the only, that point there is the only solution for both of these lines. It talked about the first point, I can't remember what it was, but one of these, it showed it was on the line, but it was only on one line, not two lines. So it would be either up here or over there, but it wasn't the intersection, okay? So there's one solution to this system of equations, and that's where it would be. And a lot of this chapter, well, this whole chapter is talking about this, but it's solving for this different ways. Sometimes it's graphing, other times it's putting in just the ordered pairs to see whether it works and so forth. But the bottom line is you want to determine what that ordered pair is. That's what you're trying to do. Okay. So I'm going to stop sharing that and I'll go back to the text. Okay. And it is right here. No, it's right there. Okay. So that's what we were talking about here. And that second point, it satisfies one line, but not the other line. Okay. This is another example. It's just another example. You plug the -2 and the -1 in to both of these equations, see whether it's balanced. This particular one, if you plug in -2 and -1 to this, it works for the first equation, but it doesn't work for the second equation because 5 isn't equal to -5. Okay, so therefore that point is not a solution, right? But now it gives you the second one. You'd put and this is wrong. This 4 and 3, it does make us. This is one of the errors. There's numerous errors in this book. Okay, unfortunately, and this is one of them, because when you put 4 and -3 in here, that's what we're doing here. It balances both. It's on both. So this should say this does make both equations true. It's a solution. Okay.
Is that the point of intercept for the two lines, or
Yes,
just the solution?
It's the same thing. That is the point of intersect. That's what the solution is. This isn't right. I'm just saying when this text is wrong here. This when you put -4 and -3 in here, it is a solution because it satisfies both equations, right? That's what we did. We proved it just by putting those values in for x and y. And you see that -1 is equal to -1 and -5 is equal to -5. So it's a solution, okay? Does that make sense, Miranda?
Kind of.
Kind
I don't
of.
know. It'll click.
Yeah, it's just this whole section's on this. So as you go through it, you'll see what I mean. I give some to try. We're not going to try them. We're going to keep on going. Now this part, we're going to solve it by graphing, okay? So here we solved it just by plugging in numbers, right? We plugged in numbers to the equation. We see whether it worked. Another way is by graphing, okay? Here's an example of two lines that intersect. So it has one solution, okay? This one, you've got two parallel lines because it has the same slope, a different y-intercept. It doesn't, there's no solutions, right? This one is two equations that represent the same slope and the same y-intercept. It just doesn't say which ones they are, but so there's infinite number of solutions. So you have three options: one solution, no solution, all solutions. Okay. There's only three options you can get when you have two equations, linear equations. Okay, then it talks about step by step. Okay, graph. So what we do is graph the first equation. We've got 2x plus y is equal to 7. And we put things in terms of, we determine what the slope is and what the y-intercept is. That's what we're doing here by putting this in terms of y. We move x over to the other side, so it becomes y is equal to -2x plus 7. So the -2 is the slope, and the intercept is 7. We graph that. By knowing that intercept of 7 up here and the slope of -2, you would go down 2 and over 1, down 2 and over 1, and you have to draw a straight line like that. That's for the first equation, okay? Now you do the same thing for the second equation. Y is equal to x minus 2y is equal to 6. And this one, they're using the intercepts method of graphing. That means you make x equal to 0, you solve for y. When x is equal to 0 here, y is equal to -3. When y is equal to 0 here, x is equal to 6. You plug those two points in here, 0 and -3. 0 and -3 happens to be, wait a minute, 0, yeah. 0 and -3 happens to be right there. 6 and 1 happens to be up there. Draw a straight line, and it crosses right here. So this is your solution, okay? Does that make sense? That's what you do when you're to graph them to find the solution. I use this method here because it wasn't in the y is equal to mx format. That's why they're saying using the intercepts method. Okay, you understand how?
But could you solve for the
Mm-hmm.
slope intercept
Yep.
form and graph it that way too?
Yep, totally. Yep.
Okay.
Yep, exactly. It's a preference thing, really. They just do if they see something that's not, by that I mean that the textbook see something that's not in the y is equal to mx plus b format, they automatically do the intercept method. So it's either one works. It should work if you do it correctly. Okay, so you do that, and then you get your point. So we got where x is equal to 4, y is equal to -1. So it would be 4, -1. That would be the ordered pair, right? So now we take this and we plug it back into both equations. That's what they're doing here. 2x plus 7, 2x plus y is equal to 7. They're putting in 4 and putting in -1 for y, solving. Make sure it's compatible. Do the same thing with that second equation. For x, they're putting in 4, y, they're putting in -1, and it's balanced. So the solution, 4 and -1 is the solution for that system of equations, okay? Does that make sense? That's really all, that's how they're doing that. These are some more you can try. We'll keep on going. And this shows you how to do it, how to solve, okay? Graph the first equation, graph the second equation on the same rectangular coordinate, determine whether they intersect, whether they're parallel or the same line, and identify the solution. If it intersects, then check to make sure the solution is correct. And checking is doing your algebra, putting that data point in both lines and see whether it's balanced or not. If it is, then it checks, okay? So this is the procedure you want to follow to graph. Okay, more examples. This one, they're both in the y is equal to mx plus b format. So that's pretty simple. You put in you put in where the intersect is, and then you go ahead and use the slope to determine that equation. That first one, b is equal to 1, so it's right here. The slope is 2, so you go up 2 and over 1, put a point there, and you have a point there, draw a straight line. It ends up being that ends up being the intersect by coincidence. I mean, this is the way it is. The second one, you've got a slope of 4 and an intercept of -1. So you get -1 down here for the intercept. The slope is 4, so you go up 4 and over 1, and you're at the same point. Draw a straight line, and so they both intersect here, right? So the lines intersect at 1 and 3. Then you take that 1 and 3, plug it back into both equations to make sure it's balanced. That's what they've done here, okay? So now they've proven that 1 and 3 is the answer. Graphically, they showed it, but now they proved it, okay? Okay, some more of the same to try. Here's another one. And okay, this one, oh, okay, the first one, they're determining what the slope is and what the b-intercept is. And they're doing the same thing for the second one. Graphing it just like we graphed it before, okay, no difference. Determining what the intercept is ends up being -1 and 2. plugging that -1 and 2 back into the equation to make sure it works. It does on the left side, it does on this one. So for both equations, that point satisfies it. So therefore, that's the system. Okay, that's the solution. Okay. So that's if there's only one solution. Okay, so we'll get to, okay. Okay, here's another set of equations. On this particular one, they're using the intercept method. They draw a little box like this. It helps you to do it, keep track of things quite easily. So when you put on this, you put x is equal to 0 for x, y is equal to 2. So you put a 0 here and a 2 there. If you put y is equal to 0, x is equal to 2. You put a 0 there and a 2 there. Real simple. And then you've got your little box, and then you can just go to your graph and plug them in. And you do the same thing for this one. When y is equal to 0, x is equal to 4. Okay, you've got 0 for x minus y or minus 4 for y. And do the same when x is equal to 0, y is going to be equal to minus 4. No, excuse me, that's just what I said. When y is equal to 0, x is going to be equal to 4. Okay. Plug them in, and when you do that, you'll see they cross right there. Okay. When you plug these in, you'll be getting a value for here and a value for the, on both axes, both times. That's what the the intercept method allows you to do. So you're actually finding a point on the y-axis here and a point on the x-axis here. Point on the y-axis here, point on the x-axis here, and then you draw your lines and you see where it meets. And in this case, it's +3 and a -1. You take that +3 and -1, again, plug it in, make sure it balances on both sides. So does this make sense, Miranda? Miranda, you there?
Yeah,
Okay.
sorry, I'm a little, I'm here.
Okay, I just want to make sure you're following it.
I guess.
Go ahead.
Well, there's one equation.
Yes.
And then so we get the point. Okay, 0. 0, 3. So the y, or -4. Okay, obviously. Yep. I don't know.
Well, wait a minute. So what?
We graph that point. So 0 and -4. So that's on the y-axis. We would put a point at -4, and then a y on the x-axis. It would be 4. But how do you know which way is that the? I mean, you just draw like a.
Yeah, you're just going to get 2 points. I wish I could. Here, well, I wish I had a better tool to be able to do this, but let me see. Let me do it. Let's. Okay, you've got one. I'm going to rewrite this thing. X minus 4 is equal to 0. X minus 1. Okay, that's what I need. I need x plus y is equal to 2, and x minus y is equal to 4.
Because we don't need any other points to. They're not using any other points.
No, you don't. So let me go back and let me go to my whiteboard and show you this. Just want to make sure I have the right equation. Okay, so I'm going to stop sharing, and we're going to share. We're going back to this thing here. Okay, I'm going to erase this. Can you see my whiteboard now? Can you see a board? Okay.
I'm following. Yeah.
Okay. So x plus y is equal to 2. That's the first one. And the second one is x minus y is equal to 4. Okay, so in that first one, I can't make a little table here, but x and y, I just do it like that. So this one up here, so when y is equal to 0, so I know, or let's do it, when x is equal to 0, I put a 0 right there, y is equal to 2, right? And below that, when y is equal to 0, x is equal to 2, right? So it looks like this. These are the 2 data points, right? And we do the same thing on the other one. I'm going to do them, and we're going to draw a line. We're going to draw a little.
So we have 2 points for 2 different lines.
Exactly. Yes.
Okay. That helps. It's
exactly. Yep. It's just clunky to do this, but on this one, if x is equal to 0, y is equal to -4, right? So if we've got 0, -4, right? And then I'm looking at this equation right here, x minus y is equal to 4. So when y is equal to 0, x is equal to 4, right? So you'd have a 4, whoops, and you'd have a 0, right? You with me? So and I've got these set of data points. So now I go on a graph. I can draw a graph with this thing here. Yeah, we'll go like so. It's like this, right? And that's a straight line. And then we do the same thing. Go here like that. Okay. So that's so now I'm going to plot my 2 points. My 4 points actually. So look at this one here. I'll get my pen. Great, I lost my pen. I'm going to have to use my mouse, unfortunately. So that first point is 0 and 2. So 0 and 2, we're just going to say is right there. Okay. 2 and 0 is right here. Right? Right on that line. So that first line looks like this, right? I can go through it. That's supposed to go through those lines, okay? And it's supposed to be yeah, I can't fix it. No. And anyway, so that represents this equation right up here. Do the same thing for this one. For x is equal to 0, y is equal to -4. So that first point, is right down here. And that second point where x is equal to 4, y is equal to 0, it's right up here, right? We're up there. And so you draw another line, and we'll make it a different color. Right? Like that. Okay, so does that make sense, Miranda?
Yeah, so it's you don't have to draw a perfect line as long as they hit the 2 points that you're graphing.
Yeah, right.
I guess it's the approximate thing kind of throws me off because I want something like
I mean, it's approximate on the graph, but you pick the point, and then you put that point back into both equations to make sure it's real, right? It's correct. You didn't make a mistake when you graphed.
True.
So that's how you check it, okay? So those are the steps. And so, I apologize for this thing doesn't look too efficient.
No, that helped.
Okay,
yeah,
good.
perfect.
So that's what I wanted to do. Okay, good. I don't want you to be confused. And I wish I would have taken, I've got another person in another class that has problems with this. And anyway, I haven't been able to figure it out for them yet or have them see it. But I'm working on it. So, okay, so we're going back to this. So that's what I was doing there. I was getting those 2 little boxes, being able to graph it, and you can see this is the answer. Then you take that answer, put it back into both lines to make sure it works, okay? And if it does, then you graphed it correctly, you picked the right point, and that point's satisfied, okay? Okay, here's another set. Now we're getting in sort of different flavors. When we say y is equal to 6, what kind of line is that? Do you guys remember how would you draw y is equal to 6?
No, that's horizontal.
That would be a horizontal line, exactly, with there's no slope. Slope is 0 because there's no x. There's no x value in this equation, right? It's just y is equal to 6. So it's a horizontal line that crosses where y is equal to 6 and hits every x value, plus and minus, okay? The second one, you can do this by this box down here, right? Use the intercept method. That's the same idea. You put x is equal to 0, y is equal to 4, down here, x is equal to 0, y is equal to 4. You put y is equal to 0, x is equal to 6, right? Y is 0, x is 6. You go ahead and graph those. Here's your y is equal to 6. And here's your other equation there. And you can see they cross right here where x is equal to -3 and y is equal to 6, right? Then so you've done this graphically, but now you want to analytically, you want to prove it. So you want to take that -3 and that +6 and plug it back in, right? So that's what we're doing here. Well, we've got, when you can only plug in on this y is equal to 6, you're only plugging in the 6 because there is no x, right? So you put the 6 in here, and lo and behold, the 6 is equal to 6. Well, we have 2 is equal to 2. Again, I think that's an error. Well, anyway, we know it's where this little check mark is the key. And then we do the same thing on this equation here. You got 2x plus 3y is equal to 12. Put in -3 for x, and that becomes -6. Put in 6 for y, it becomes 18. -6 plus 18 is 12. 12 is equal to 12. The solution is -3, and 6 is correct, right? Yeah, this is just, you don't need a 2 and 2 there. It doesn't make any sense. I should write these down as I find these little errors. Let me put that down. So what page is that? Great, it's on the other side. Just a minute. 585, okay. 585. Okay, I'll try to keep track of them. Okay, so that's questions on that. That makes sense. Again, it's just two straight lines with one solution. There's only one solution there. Okay, here's another one. Y is equal to 1/2 x minus 3 in x minus 2y is equal to 4. So we're graphing we're going to graph them both. The first one's already in the slope-intercept form, so we can just pick out the slope as 1/2. The intercept is -3. And the second one, we're going to use the intercept method. So x minus 2y is equal to 4. So when x is equal to 0, y is going to be equal to -2 right there. When y is equal to 0, x is equal to 4. We go ahead and graph them. And lo and behold, when we graph them, they end up having a parallel lines, right? End up being the same slope. So this particular one up here, there's no solution, right? You end up saying no solutions because they're parallel lines. Okay. Yeah, it's no solution. There are no ordered pairs. Okay. Okay, here's another one. Y is equal to 2x minus 3. So one's in the slope-intercept form and the other isn't. So you do the same thing. That first equation, you've got m is equal to 2. B is equal to -3. The second equation, you put this into the intercept form by setting y is equal to 0. X is equal to 3/2. That's right there. When x is equal to 0, y is equal to -3. Plot those points, that and that point, draw a straight line. And when you do that, you see that they overlap, right? This is the same thing. This top equation is exactly the same as the bottom one. So there's infinite number of solutions that satisfy both because it's on the same line, right? And when I say infinite number of solutions, it's got as many x values as you can go because this arrow goes to infinity or negative infinity. This arrow goes to positive infinity on the x-axis. So you have infinite number of solutions, okay? Okay, just another one. Okay, so determine whether the number of solutions, to determine the number of solutions of a linear system. This is really what you need to know. Two intersecting lines, you have one solution. Parallel lines, you have none. And same lines, it's infinity, okay? Infinitely number of solutions, okay? So those are the three options. So know these, okay? Because on your quiz, you'll have this, okay? You'll have to determine whether the lines are crossing. You're going to have to graph things, okay? There's quite a bit of graphing on the quiz, and I give you graph paper for it. So here's an example. You've got this and this. The first step is you use the slope-intercept form. So this one would be -1/2 for the slope, and b would be -3. And you solve the second one. We solve the second equation for y. Okay, we get the same thing, right? Oh, no, we don't get the same thing. We have the same slope, but we have a different intercept, right? I can show a graph on this. I guess they're not. Well, anyway, so that's the same slope, and so they're obviously parallel lines. One goes through the y-axis at -3. The other one goes through the y-axis is -2, okay? You wouldn't know that by looking at this. They don't look that way, but when you do you put them both in the same form, then you can obviously see it, okay? Now there's a couple tables here that are a little confusing, and don't get hung up on them. Just remember, just know this: two intersecting lines, one solution; parallel lines, none; same lines, infinite number. I'm not going to ask you what's coincident and what's not, okay? Because I don't think it's relevant. It's not used, okay? So don't worry about that. Yeah, it's coincident and inconsistent. You can read through this, but consistent if a system of equations is at least one solution, inconsistent if there's no solution. So if they're parallel lines, it's going to be inconsistent, okay? Because this consistent would be lines that intersect or overlap, because it would be infinite numbers. So consistent for two of the three examples, inconsistent for one. Okay, it gives you some. Okay, there are two equations are independent if they have different solutions. They're dependent if all the solutions of one equation are all solutions of the other equation. Okay, but again, there's three different flavors: intersecting, parallel, and overlapping. You can call this coincident if you want, but it's overlapping. Okay, it's the same line, and that's what they're showing there. Okay. Okay, another example: without graphing, determine whether these are, and classify them. All you have to do, by classifying them, as far as I'm concerned, all you have to do is determine whether there's a solution or no solution, okay? And so we're using analytics to do this, right? In this particular case, yeah, it's already in the slope-intercept form, so you know what the slope is and you know what the intercept is. The second one, you put it in the slope-intercept form, and then you can look at them, okay? When I say analyze without graphing, that's pretty well what you got to do. You got to figure out what the slope and intercept is. Then you can look at those two equations and determine whether they're intersecting, they're parallel, or they're overlapping. Okay, you don't need to graph it. Okay, more of the same. Here's another example: determine the number of solutions. Okay, same idea. You determine, yeah. They put both in the slope-intercept form because that's really what you have to do. It doesn't do any good to figure out what the intercepts are, right? You wouldn't do that if you weren't graphing it. So the only way you do it is determining what the slope is and what the intercept is, and then comparing the two. In this particular one, you've got a -2, you've got a slope of 1/2 or 1/5. So these are going to be intersecting. You don't need to graph it to determine that. You just know it because of the data. Does this make sense? Okay, you don't have to graph this to answer the question. But you do have to graph it, or you have to do a little more work if you want to know what the solution is, right? Because there's just one solution, but it's not asking you that. Okay. Get out of the way. Why they have it on. Okay, this is the next equation. It's on a different page. Doesn't make any sense. But anyway, same idea on this. If it's in the mx plus b format, you just leave it. If it's not, you go ahead and figure out what it is. And that's, they don't go through the answer in this, but you can see on this one, it's got the same slope, exactly the same slope, and has the same y-intercept. So therefore, they're overlapping. They're coincident, right? Okay. So then it goes through, it shows you how to, the step-by-step for solving system of linear equations. This one is by graphing, okay? Okay, here's an example of a linear equation. But two linear equations, and they're asking to solve for it analytically, right, and graphically. So it seems like a simple little problem. You've got Sandra is making 10 quarts of punch from fruit juice and club juice, or club soda. So she's got two ingredients. The number of quarts of fruit and club soda has to equal 10. And the ratio is that there's 4 to 1. Fruit juice is 4 times the number of quarts of club soda. So you end up with two equations, right? One is that fruit juice plus club soda equals 10, right? Equals 10 quarts. The other one is fruit juice is equal to 4 times the club soda, because it says the ratio, or it says that the concentration is 4 to 1, right? So you have two equations. So with two equations, you can go ahead and solve for one solution. There's only one solution that meets these two requirements. You can graph it. And that's what they're doing right here on the, again, the F becomes the y-axis. The C is the x-axis. And if you look at it like that, you've got F is equal to 4C. That was the second equation. And so that means that the slope is 4 and there's no intercept. So it's right down here at this point right here, right? And so to graph it, you would start here. You go up 4 and over 1, up 4 and over 1. And that's how you get this line. The other one is F plus C is equal to 10. Put this in y-intercept form. So it becomes F is equal to minus C plus 10. So the minus C means the slope is -1. And it starts where F is, or the y-intercept is 10. So it's 10. It goes down 1 for every 1. And that's why you've got a straight line going down. You see where they cross at 2 and 8? That's the solution. It means you've got 2 quarts of club soda and 8 clubs of fruit juice. Okay. Does that make sense? I mean, that's how you would apply this. Okay. Okay, so I think okay, we're done. Okay, so let's take a 10-minute break. We'll come back at 6:12, and then we'll go over some of the homework type problems. Okay, so 6:12 we get back together. Okay, actually 6:13 we'll say. Okay, see you at 6:13. Okay, I'm gonna get a cup of coffee. Oh, turn off my recording too. At least I'll remember it this time. Stop.